Hi everyone. Now let's take a look for the topics of analysis of variance, or we call as ANOVA, and these topics will cover one-way ANOVA. In the previous topics, we have learned about the t-test and the significance of the difference of the mean of the two samples of two population. It can be judged or can be determined through the either z-test or a t-test that we have learned the topic before. Now, what happens if the population or the number of the sample is more than two samples? Therefore, that's that we cover in this topic, and is the focus of this topic, which is the roles of the ANOVA is a method for testing the hypothesis that there is no difference between two or more population means. And these ANOVA techniques enable us to perform the simultaneous test. As such, is important tools of analysis in the hands of a researcher. Compared to the previous topics, which is we are focusing in two samples, how we can determine the significant difference between the two samples, and therefore we using a t-test. Now, in order to determine is there any significant difference between two or more number of samples, therefore we need to use ANOVA test. Okay, let's recall back when when there are more than two means, it is possible to compare each mean with each other using t-test. However, conducting multiple t-tests can be lead to severe inflation of the type A error rate. Okay, that we have discussed in the previous topic regarding the error 1 and error 2. So ANOVA can be used to test different among several means for significant without increasing the type 1 error rate. And the ANOVA is important for situation where we want to compare more than two population. In such circumstances, we do not want to consider all possible combinations of two population at a time because it will require number of tests. The one-way ANOVA compares the means between the groups you are interested in and determines whether any of those means are statistically significantly different from each other. Meaning that in order to using a ANOVA test, we will have more than two sample, which is 3 sample and above. Specifically, it tests the null hypothesis, which is mu1 equal to mu2 equal to mu3 and etc., which is mu k, and where the mu is a group mean, the value of the group means, and k indicates the number of groups and indicates the number of the sample population or number of sample. And now let's take a look at the properties of ANOVA before we determine how we can calculate and how we can determine the ANOVA test. The first properties of the ANOVA is there are k random number samples of k populations, meaning that, like I mentioned just now, in order to use an ANOVA test, we need to have more than two samples from more than two populations. Number 2, the k samples are independent of each other. This means that the subjects in one group cannot be related in any way to subjects in another groups. Okay, this can be example like if you want to compare 3 different races in Malaysia to determine the score of the students' achievement in mathematics according to their type of ethnicity or races, meaning that we will have more than two races. Therefore, this is the example of the second properties. Number 3, the population are normally distributed, and therefore in using ANOVA, since ANOVA is a parametric test, therefore we will to ensure that the data that we have used must be normally distributed. Number 4, the population have the same variance, characteristicity, which is each treatment group had the same population variance, which is sigma square. This is the assumption in order to using the ANOVA test. Now, let's have take a look how we can determine the ANOVA test. The partitioning of the total variability into components. In order to determine the ANOVA, which is the F test, we need to, this is the core content that we need to know, which is the sum of the squares total, which is equal to sum of squares treatment plus sum of squares error. In interval notation, SST equal to SST treat and plus SSE, where SST is the total sum of squares, SS treat is sum of square of due to the levels, SSE is the sum of squares due to error. Like I have mentioned just now, SST is equal to SST treats plus SSE. This is the first equation. And equation number is also known as the sum of squares of identity. And it can be written as summation ki equal to 1, summation nij equal to 1, in bracket yij minus y bar dot dot double dot into a close bracket square, and equal to summation of ni y bar I minus y bar square plus summation of yij minus y bar square. Other formula or other notation that we need to know in order to calculate the ANOVA test is decomposition in 2 can be further simplified as follows. So based on the previous equation, we can simplify that SST is equal to summation of yij minus y bar square, and it can equal to summation of yij square minus square of y over n, number of n, for the SST, and for the SS treats, it can be equal to m times with the summation of yi bar minus y bar square, and equal to summation of yi square over ni minus y square over number of the sample of y. And using the first equation, the sum of square of error SSE can be calculated by SST equal to SS treat plus SSE. Okay, for continuing from that, we need to determine the degree of freedom for SST and SSE. To determine the degree of freedom for SST is given by n minus 1, and that for SST3 is k minus 1. And the degree of freedom of SSE is given by n minus 1 minus k minus 1, or equal to the number of the sample minus of k, which is the different number of the group. And this measure of variability is known as the mean square, MS. And MS treat is equal to SS treat over k minus 1, which is the number of the different group minus 1. And MS error is equal to MSE is equal to SSE over n minus k, which is the number of the sample minus the number of group. And these quantities are used to calculate the test statistic. After we have determined all that equations, now we need to determine another aspect, which is the null and alternative hypothesis for one-way ANOVA. This is very important to determine the hypothesis, either to reject the null hypothesis or fail to reject. And for the null hypothesis, mu A equal to mu B equal to etc. until mu the number of the group. And for the alternative hypothesis, mu A not equal to mu B until it's not equal to mu number of at least one of the mean is not equal. Now, after we have figured out our hypothesis and we have determined all the value of the calculation of f-test is a time to compare the f-test with the hypothesis that we have determined, and therefore we need to determine the value of the f-test. F-test is to test the hypothesis of the ratio from the two variances. In one-way ANOVA, the f-test statistic is given by based on the value that we have get, which is MS street and MSE. We are dividing these two values, and it will contribute the value of the f-test. And the f distribution is followed with k minus 1, n minus 3, and degree of the freedom, and the direction or region of the one-way ANOVA is always in the right tail of the f distribution curve. And in other words, after we have determined the f-test value, we are comparing the f distribution's value in the statistic table. And since this is f-test, and the value we are determine is always depend on the region between of the f-test and also in the f value in the statistic table. Okay, and that's why we will determine either we will reject the H0 or fail to reject H0. From based all the formula that I have explained just now, we can translate or we can transmit into this ANOVA table to make it easier way to do the calculation of the f-test. So in the first column is a source of variation consists of treatment, which is between levels, error within level, and total. The second column is sum of square, consists of the value of SS street, SSE, and also SST. SST is a summation of SS street plus SSE. And the degree of the freedom, like I mentioned just now, how we can determine between the treatment and of the error, k minus 1, n minus k, and the lastly for the total degree of freedom, it become n minus 1. And then the fourth column is a mean of square. Mean of square for the treatment is MS street, and for the error is MSE. Based on these two values, we can put on the last column, which is the value of the test statistic, which is f test, which is equal to MS street over MSE.